Imagine your ESP32 controlling a smart lock at home. If it sends messages in plain text, anyone on the same Wi-Fi can intercept and replay them, unlocking your door without you ever knowing. That's exactly the risk TLS solves. It wraps your communication in a secure tunnel, ensuring confidentiality, integrity, and authentication. In this lesson, you learn how TLS works conceptually, how ESP32 supports it with ESP IDF, and how to implement it in your own code. By the end, you won't just understand the theory. You'll know how to lock down your ESP32 project so they can safely talk to cloud services and APIs. Think of TLS as two people agreeing on a secret code before talking in public. The ESP32 first says, "I'd like to speak securely. Here are my options." The server responds, "We'll use this method, and here's my ID." That ID is the certificate, signed by a trusted authority. Once verified, both sides agree on a temporary session key and start talking in code. From that moment, even if someone is recording the network, they only see gibberish. This handshake, hello, certificate check, key exchange, and encryption is the backbone of every secure IoT session. When you work with cloud platforms, TLS isn't optional, it's mandatory. AWS IoT, Azure, and Google Cloud will reject plain TCP connections outright. ESP IDF handles this with its ESP TLS component built on MQTT TLS, which uses the ESP32's crypto hardware to speed up encryption. As a developer, you mainly provide the right certificates and endpoint details. The library manages sockets, key exchanges, and cipher suites. Whether you're fetching JSON over HTTPS, publishing data with MQTTs, or downloading firmware securely, TLS ensures your project is production-grade instead of a vulnerable prototype. In this code, we're showing how an ESP32 can make a secure HTTPS connection to a server using TLS. First, we include the required ESP IDF headers for system functions, logging, and TLS. We also define a tag, TLS_demo, for log messages. Next, we provide the server's root certificate authority certificate. This ensures the ESP32 trusts the server it's connecting to. In the app_min function, we set up the TLS configuration by passing the certificate buffer and its size. Then, we call ESP_TLS_con_HTTP_new with the server URL and our config. If the connection is successful, we log that TLS is established and then clean up the connection. If not, we log an error. Essentially, this code is the foundation for securely connecting your ESP32 to any HTTPS server, protecting data from interception or tampering. Here's a list of TLS errors you'll run into and their practical fixes. Most failures aren't about broken code, they're about environment mismatches. Certificates expire or don't match the host name, the ESP32's clock is off, or the device runs out of memory during the handshake. I've seen engineers spend hours debugging code when the real issue was just an unsynced system time. Knowing these patterns helps you troubleshoot faster and keeps your focus on the actual application. To make TLS second nature, you need to use it. Start simple. Fetch JSON securely from an HTTPS API like OpenWeatherMap and print the result on serial. Then, move to MQTT over TLS by connecting your ESP32 to Mosquito on port 8883, publish and subscribe securely. For deeper practice, spin up your own HTTPS server with a self-signed certificate and connect your ESP32. Each of these challenges forces you to handle certificates, debug handshakes, and think about real-world deployment issues. That's how TLS becomes less theory and more of a habit in your projects. You've seen how TLS shields ESP32 communications from eavesdropping and tampering, how ESP IDF and MQTT TLS simplify secure connections, and what pitfalls to watch out for in real deployments. You also explored mini projects that transform TLS from a scary acronym into a tool you can actually wield. With this knowledge, you can now connect your ESP32 to cloud platforms, APIs, and brokers with confidence, knowing your communication is protected. Security isn't an afterthought, it's the baseline for professional IoT engineering.